All right, here we go. A little bit of review for our quiz this weekend. Make sure you guys are watching this before you practice.
So third block teachers, if you have first lunch,
A bonus announcement for you guys. Just like you're here. All right, here we go. So we're going to graph this quadratic function and find all the attributes. All right, so first things first. What form is this in? So I look here and I say x squared, x, and a constant. That is in our standard form. And you can go in lots of different orders here, but I'm just going to kind of pick and choose as we go. So how it opens is all depending on that first number here, which is just a positive one. So since it's positive, we know we're going to open up, which will always give us a minimum. And if I want to get the axis of symmetry in our standard form, you've got two options: graph it or solve it. So if I want to graph it, put it in your graphing calculator. If you want to solve it, you're going to use x equals negative b over 2a in order to find your x value. Then you just get your y value from the end. So your y value is always going to be this guy. All right, but we're not going to use that until our vertex. So I already know the y value of my vertex is negative 1. So let's find the x value, because that's going to go right here. And it's also the axis of symmetry. So negative b over 2a. So I've got opposite of b. It already is negative, so I'm going to make it positive over 2 times a is 1. So that's 2 over 2. And x equals 1. That's our axis of symmetry. So that also is our vertex x value. So you'll see I just filled that in as well. So that tells us that our vertex here is going to be 1, negative 1. All right. Ooh, I lied to you. I'm sorry. It is 1 for sure. Take this part back. The y-intercept is this guy. I mixed up my y values in my brain, sorry. All right, so the y-intercept we can pull from the end, so that's going to be 0, negative 1. Now that we have the x value of our vertex, we will go ahead and plug that into our equation to get the y value. So that's x squared minus 2x minus 1. So we're going to go x squared minus 2x minus 1. And that's going to get us our y value. And after you plug that in, you will get negative 2. All right, so there's our vertex, 1, negative 2. So right 1, down 2. We know that the y-intercept from what we just did is at negative 1. We can reflect it across our axis of symmetry in the middle. So essentially reflecting it across the vertex. All right, end behavior. Left and right. Well, we know that this is a parabola, so that's not going to be my final move here. But that means my end behavior on both sides are going to be rising because we're going up. We're opening up. It will always be the same. All right, so that means let's keep a graph in before we do increasing, decreasing. All right, number of zeros here. Well, again, we know that it's opening up and it's under the x-axis, so we will have 2 of them. Domain is always negative infinity to infinity with a parabola. All right, so let's go ahead and just graph this. Okay, so that means that my range is going to start at our lowest y value, which is the y value of the vertex here of negative 2, and then it's going up, so we got to meet it at infinity. It's not in factored form here, so we can just kind of say, nope, not applicable. And increasing, so left to right, we're going to start with decreasing, then we're going to go to increasing. So if I decrease, I'm going to go negative infinity all the way to my vertex where it turns it around, and remember, we always use x. And then I'm going to increase from that same x value of 1 all the way to infinity. So kind of bringing in a lot of our units here. Let's go on to that next one. Type of format here is also standard form. And this one, because it's negative, is going to open down, which is going to give us a maximum. And it's in standard form again, so you can either graph it or you can solve for our axis of symmetry and our x value. So I'm going to solve x equals negative b over 2a. So opposite of b, positive 8 over 2 times a, which is negative 2 here. So that's going to get us 8 over negative 4, which will get x equals negative 2. So I know right now that my x value of my vertex is negative 2. And I'm just going to plug that into my equation to get the y value. So negative 2 times x squared minus 8 times x minus 4. And I would just put all of that into my calculator and get 4. All right. Let me double check here. All right, there we go. Good. So now I've got negative 2, 4. So left 2. Up 4, there's our vertex. We know it's going to open down, so that tells us a couple things here. So I'm going to go down 2, left 1, down 2, right 1 here just to kind of get the move of it. All right. Y-intercept is always the last here in standard form. That's why we love good standard form. So that's going to be 0, negative 4. So we can actually make sure we have a more accurate graph. That was pretty close. Take it. All right, number of zeros here are going to be 2. We don't know specifically which ones, but if you put it in your calculator, you absolutely can know. Domain, always negative infinity to infinity. Range here, because it's opening down, is going to go negative infinity all the way to our highest point, which is the y value of the vertex at 4. Okay, and on the next, not in factored form, NA. End behavior left and right are going to be falling because it's going down. And we're going to start with increasing as we go left to right. So negative infinity all the way to our x value of negative 2. And then we're going to decrease from negative 2 to infinity. Make sure you guys are watching this video as a key, not as notes. So you should be watching this video after you've already tried it. All right, this one is in vertex form. And our a value here is positive, so we know we're going to open up, which gives us a minimum. And vertex form is way nicer because I can just pull the vertex. Remember, switch the sign, keep the sign. So it's going to be 2, negative 2. And that tells us our axis of symmetry is 2, so we don't even have to do anything special here. That's awesome. All right, a couple other things we can pull. Our y-intercept is still 0 something. So I can plug in 3 times 0 minus 2 squared minus 2. And that's going to get us our y value here of 10. So let's do some graphing. So we're going to go 2, negative 2. And we know that our slope, our first slope is up 3. So we're going to get pretty steep here. And our y-intercept is at 10. And then we can reflect it across. There we go. All right, this will give us a fairly accurate graph, if I can draw anything here. Oh. Okay, I'm going to use that. Okay, so my number of zeros here are going to be 2. It crosses the x-axis here twice. And my domain is still going to be negative infinity to infinity. That will never change here. Now it's opening up, so I'm going to go lowest point to infinity. So my lowest point here is my y value of the vertex, excuse me. It is not in factored form. End behavior, they're both rising, increasing and decreasing. So we start with decreasing, negative infinity to my x value of the vertex, and we pick it up at the x value and we increase until infinity. All right, let's check out this backside type of form here. Again, we're talking about vertex form. my personal favorite. A value is negative, so we're going to open down, which gives us a maximum. And I'm going to find my vertex, switch, and keep. Positive 4, 1. Told you to switch it and forgot to do it myself. All right, so that tells us my axis of symmetry is at 4. So I'm going to plot 4, 1. Okay, we know we're going to open down, which tells us a couple things. Tells us that we're going to have 2 zeros here. And let's see our y-intercept. Let's just plug that in. So if I plug in a 0 like we've been doing, I'm going to get -7. So that helps us graph it a little better. Here's my point at -7, and I'm going to reflect it over 4 spaces on each side. There we go. And that's going to get us a pretty accurate graph. Wow. Look at the art skills here. Just crazy. Awesome. All right, so my domain's still -infinity to infinity, and my range is opening down, so we're going to go -infinity to my y value of 1 on the vertex. Still not in factored form. One day it will be. They're both falling because I'm opening down. And then I increase on the left from -infinity to my x value of the vertex, and then I start to decrease when I turn around from 4 to infinity. All right, these ones are just practicing putting it in your calculator and letting your calculator help you out. So I'm going to put this into my y equals on my calculator. Where every t is, you're going to use that xt theta n button. Then it asks for what's the maximum height of the ball. Okay, that is asking for your maximum or your vertex, and it's actually just asking for the y of your vertex. So you would go second calc. Let me make sure I'm telling you here. Let me open up my calculator. You guys should be doing the same. So you would go second trace, and then you would click maximum, do your left boundary and your right boundary, and press enter, and your y value of that vertex is 26.5 feet. So that's as high as that ball goes. So remember, height is our y value, time is our x value. So this is where it asks us, well, how many seconds is it going to take to reach that maximum height? Well, that's our x of the vertex, because remember, x is our time. And you already just did that, so it should be right there in front of you, 1.25 seconds. All right, when will the ball hit the ground? That is asking us for our 0 and our positive 0, because it is a parabola, so it's going to do this. We don't care. That's not real life. We just want this one. All right, so we're going to ask for our 0, and you're going to go second trace 0, and do your left boundary, right boundary, and you will get 2.54 seconds it's going to hit the ground. How high it's going to be after 1.9 seconds, this is where you just need to press trace 1.9, enter, and that essentially just says, hey, if my x value is this, what's my y value? Okay, because I'm asking for the height, so that's my y value. So you will get 19.74 feet high after 1.9 seconds. Number 9, you have to add a second equation. When will the ball be 22 feet high? So at 22 feet high, that's our height, you have to go into your y equals and do y equals 22. So you're going to get your parabola, and then you're going to get a horizontal line, and you're looking for these 2 points. That is your intersection, okay? So once you put in y equals 22, you're going to go back to your graph, and you're going to do second trace, intersect, and then on each intersect, you'll do your left bound, right bound, and you will get your first answer of 0.72 seconds is where they're going to intersect. That tells you at 0.72 seconds, that ball is going to be 22 feet high. then it's going to go even higher, and then it's going to come back down to 22 feet again. So we're going to do our second trace, intersect, left bound, right bound, and you will get 1.78 seconds for your second time it's that high. All right, we're going to try this same thing again. So you're following the same process. Go ahead and put this into y equals maximum height of the fireworks. So that is our y value of the vertex. And you should be getting 325 feet. Make sure your left bound, right bounds are correct. And how many seconds is that going to take? So again, after you've found your maximum, you should have both of these answers, 3.75 seconds. X is always time, all right? So if you're getting confused, X is anything having to do with seconds, and then Y is anything having to do with height. All right, when will the firework hit the ground? So again, that's our 0. And that will be 8.26 seconds. How high is it going to be after 6.4 seconds? So remember, we're going to go trace, then 6.4, enter. That gives us the X value, and it's going to kick us out the Y value of 212.64 feet. If your calculator is rounding differently, that is a-okay. When will the baseball be 280 feet high? So again, you got to go into your y equals, put in a second equation of y equals 280, and you're going to look for where that 280 intersects. So you're going to use your intersect. You have to do it 2 times. So the one on the left is going to be after 2.07 seconds. And your intersection on the right is going to be after 5.43 seconds. That ball will be 280 feet high. Or a firework, sorry. That's a firework. We have to change that. Typo. All right, please, please, please make sure you're asking us questions. Probably a big thing you're going to have trouble with is seeing your graph. In this Calculate 84, you can 2-finger pinch in and out, all right, to help zooming. Good luck.